We are working on graphing today, and specifically we're going to be graphing linear, so they're going to be lines, and we're looking at inequalities. So before we get to inequalities, let's just remind ourselves how we graph a regular old line. That's an equation, has an equal sign. So we're going to make some steps, and I know that you guys know how to graph a line, but the steps are going to be real important when we get to the new stuff on the second example. So bear with me. Steps when you're graphing a line. This line's an mx plus b. We usually like it to be an mx plus b when we graph. So we're going to make that kind of our first little thing to think about. And just to recap, so we're all on the same page, remember m is your slope and b is your y-intercept. So over here to the left, we're going to graph the y-intercept. So on my example, it's -1. So I'm going to plot that on the y-axis, and I'm going to count my slope, which is 3/1. So up 3/1. We could also go down 3 and left 1. Same idea, same line. Okay, so we plot the y-intercept, we count the slope. Now, realize, you guys, that when you look at a line on the graph, that line is showing you all of the solutions to your equation right here. So I'm going to make a note right here that we plot the points, so that way we can see the solutions. And all of the solutions to this equation, there are a ton of them, x and y values, they're points on the line. So all the ordered pairs on the line, those are solutions to my equation. So for example, let me show you what I'm talking about. Now, if I looked at a point on this line, so maybe I'll look at this one right here. That's the ordered pair 1, 2. That is a solution to this equation. The 1 is the x value, and the 2 is the y value. And if I plug those in, I can prove to you that that's a solution. So if I plugged in 2 for the y value, and 1 for the x value, kind of like this, 3 times 1 is 3, minus 1, that equals 2. Okay, so realize, and I'm going to make a note at the top here on my paper, that's what a graph does. A graph shows you the solutions to something. Let's say graphs show solutions. Okay, that's a big idea today. It's going to be really important when we go and graph this new stuff here. So a graph, it shows you all the solutions to an equation or an inequality. Okay, so this first one, this was an equation, like I said, and it was an equal sign, but notice that down here, the difference is we're looking at inequalities. Okay, so I see a greater than or equal to sign instead of an equal sign. It's still y on the left, and it's still 3x minus 1 on the right, but this inequality sign changes a lot about what's happening in this problem. Now, if I kind of think about my steps, and if I kind of compare it to the top here, the first step is the same. You still want to look for y equals mx plus b. It's not an equal sign anymore. It's a greater than, less than, whatever. But you still want it to be an mx plus b. And you're going to plot the points like normal. So that's kind of like the first step, if you will, the first thing I want to think about. Plotting the y-intercept and counting the slope does not change. So I'm still going to start at -1, and I'm still going to go up 3/1 to count my slope. That is not any different. Now, the two places that this inequality sign is going to be different from when it was an equal sign happen right now. Okay, the points, that's normal. The two things that you guys have to know and that are different when it's a greater than, less than, whatever, the first one is you have to figure out what kind of line it is. Which sounds weird, I know. So you got to figure out what kind of line is it. You have two options. It could be a dashed line, or it could be a solid line. And solid is what we're used to drawing. So a lot of us will just automatically draw the solid line, but you got to be careful. The symbol tells you what kind of line it is. If, like my example here, if the symbol has the or equal to, it has the solid line underneath the sign, then it's solid on your graph. Okay, so the or equal to's, those are solid. If it doesn't have the or equal to, and it's just greater than or less than, those are going to be dashed lines on the graph. Okay, I have it on mine, so I'm going to go ahead and draw a solid line, which makes it seem like a normal problem still. The second thing that you have to figure out, okay, so this is kind of like the first new thing. The second thing that you have to figure out is where to shade. Which, that sounds weird too. We've never had to do that before. If you guys remember when we graphed on the number line, we always had to do like open circle, closed circle, and like which way do you shade? It's kind of the same thing here. Okay, so shading, you're either going to shade above the line or below. Okay, and if it's a greater than or equal to, you shade above the line. If it's less than or equal to, you shade below the line. So let me kind of show you what they're talking about here. And what I do is I kind of put my pencil like horizontal like this on the y-intercept. Now this is a greater than or equal to, so I want to shade above the line. You want to look where the y value, so here's the y-axis. You want y values that are greater than 3x minus 1, the line. So I want all the y values that are above, so I'm going to shade on this side of the line. Kind of like above, where the y-axis is above that y-intercept. Now the reason that you shade and the reason we think about a different kind of line all has to do with the signs and all has to do with the solutions to this inequality. Now, I'm going to ask you, like on the quizzes on the test, I'm going to say, give me a solution to this graph, this inequality. Any part that's shaded on this graph is a solution. So maybe just like, let's randomly pick a point like right there. That's the ordered pair, -2, +2. I can test that. So if I plug in 2 for y and -2 for x, that should make this true. Let's see, 3 times -2 is -6, minus 1 is -7. And yeah, 2 is bigger than -7. So that was a solution, that worked. Okay, the line, and again, if you go back to when we graphed on the number line, when it was a closed circle, that meant that that number worked. So if it's a solid line, all the points on the line make this true. Okay, so be aware, the graph still shows you the solutions. All right, so let's do a couple examples. I plot the points like normal, so I'm going to start at 3 on this first example, and I'm going to count my slope, up 2, over 1. Now, before you go crazy and just draw the line, I need to think about it. It's either dashed or solid. This does not have that solid line, that or equal to line underneath the sign. So this is an example of a dashed line, which would look like that. That means that the points on the line are not a solution. They do not make it true. Okay, this is the less than, so I need to shade below the line. So it would look like this. If you don't like remembering the less than, below, whatever, if you don't like remembering that trick, you can always test 0, 0. To figure out where to shade. So let me show you that. 0, 0 is right there. It's real easy to plug in. If I plugged in 0 for x and 0 for y, and I kind of figured out what this thing would look like, let's see, that'd be 0 is less than 2 times 0 is 0 plus 3. 0 is less than 3 is what I would be looking at. think to yourself if that's true. 0 is smaller than 3. Since you shade where the solutions are, if 0, 0 worked, you would want to shade on that side of the line where 0, 0 was, which is exactly where we shaded. Okay, so if you don't like this little trick right here, above and below, you can always test 0, 0 and see if it works. The next example is in standard form. We want to put it in mx plus b. So I'm going to subtract 3x. And then divide by -5. Now, here's where you have to go back and remember when we solved inequalities. Remember, if you divide both sides by a negative, you have to flip the sign. Okay, if you forget to flip the sign, you're going to shade the wrong way. It was a less than or equal to. It's now a greater than or equal to. That would be positive 3/5 x minus 2. Do not forget to flip the sign when you multiply or divide by a negative. All right, y-intercept is -2, and I'm going to count up 3 over 5. Okay, this one's got the solid line underneath the sign, so it's solid on the graph. Let me show you test in 0, 0 if you're interested. So there's 0, 0. If I plugged in 0 for x and for y, 3/5 times 0 is 0, minus 2 is -2. Okay, 0 is bigger than -2, so I would shade where 0, 0 is. And again, if I just remember the trick, it's a greater than, so I'd shade above the line. Ooh, this next one's weird. Some of us still have a hard time remembering if it's just x, is it vertical or horizontal? So if you remember, I make a table. They're trying to say x is always 5. So fill in 5 and then pick anything you want for y. And I just got to plot those 2 points. So 5, 1 is there, and 5, 2 is there. So it's a vertical line. It does not have the solid line underneath the sign, so therefore it's dashed. And, ooh, that trick, there is no above or below. So I don't know which way do I shade, and that's where testing a point really comes into handy. So I'm going to plug in 0 for x. 0 is not bigger than 5. So I don't want to shade where 0, 0 is. I don't want to shade to the left. I want to shade the other way. That's where all the answers exist. Okay, on your last example, you want to divide by -2 to get it into mx plus b. You divide it by a negative, so you have to flip the sign and make it a less than or equal to. The slope here, you guys, is -1/2. So be real careful. And then that's plus 1. So I'm going to start at 1 and go down 1 over 2. This is a solid line because it's got the solid line underneath the sign, the or equal to. For your shading, this is a less than, so I'm just going to remember the trick. If it's less than, you shade below the line.